Welcome to the DESI ASTRO. In this Python tutorial, I am going to let you learn that how to do a 1D convolution of a one-dimensional data, okay, under different modes. So modes will know later. Okay, so convolution is basically a mathematical operation between, say, two discrete functions, f and g, and which is marked by this strict representation of between f and g, and both are function of x. So this can be defined as a sum over u over the all of space, and it's a function of u. And then the second function you have shifted on the x-axis, okay, by certain amount, and that function is called input, and f is called your kernel of the convolution, okay. So this has a wide implications in your image processing on your 2D data, like for image filtering, signal processing, like blurring the image, smoothing the image, edge detection, and so many filter mechanism it can perform on your 2D data. So for time being, I will do only 1D convolution. So in 1D convolution, you can understood that this is like overlap between two functions. Okay, suppose you have in terms of continuous function, you have sin x and cos x. So just you shift a sine function with respect to cosine on your x-axis, and then move that function along the towards the your cos axis, cos function, and see how much area is overlapping. So that overlap is represented by convolution. Okay, so this time I am going to do it using Python coding on a simple 1D data. So let's do it. Okay, so for doing that, I need to import libraries. So I will use Numpy. So here import Numpy as NP. Okay, so this will take care of array, and then I will define x and y array, okay, as 1D data, right, not 2D. So I can define x as np dot array and 1 2 3 5 6 and 0, okay. And second, I can define y equal to np dot array, there should be a square bracket, and then I can give -1 -6 -6 9 8 5 0 1, okay. So both have the same size, right? 3 3 6 2 8. So 1 2 3 4 5, yeah, right. So both are the same. But in mistake, there should be a square bracket also, okay. So we got two array. It can be also a different lengths, doesn't matter, okay. So now I will convolve it, okay. So do convolution. So for that, type here con and give. So con is basically your variable. You can do anything as per your convenient name. And type here np dot convolve, okay, and see what it takes. So this will take your two array and mode, okay. So mode full is like your full, okay. And okay, so let's do it first. So pass my two array x and y, right, and run it and print convolution. So here you can see that you have the and you can also give the mode equal to full. So this is by default, right? Nothing is changed. You can see if I block it, then same thing is giving. So I will just put here mode full. Okay, so here you can see that like you have a total of like 8 1D array for a single, and you have check the length 1 2 3 4 5 6 7 8 9 10 11 12 13 14 and 15. Okay, so this is like gives a different size than our previous two. Okay, so you can I can show you here that how this okay, so full will give output shape of n plus m-1. Okay, this is give shape of n plus n-1, right? So and you can this will output shape is like 8 plus 8 minus 1. Okay, totals of 15. Okay, so we have 15, right? Similar stuff you can do using for the mode so okay, so just copy paste it and I will do here 1 and I will change my mode to valid. Okay, valid mode, and we'll check. Okay, so here you can see that this time you have output is coming like only one. Okay, there is only single number in that output. So let's check it in that. Okay, so here you can see that in the valid mode, right, we have max m plus n and minimum m plus n. Okay, so this conversion product is only given to the point where the signal is completely overlap. Okay, so I can put here. So just to give a comment here. So this convolution so this is like add only for like where you like your data from the both array coincides. Okay, so this is like give only at 29. Okay, now similarly you can give the third one, and also you can check the shape. So here it shape is this one, output shape, right? So this is your output shape of this format. Now third one you can do, right? So third one you can do, here we can give same. Okay, now run it. So here you can get, we have got 1 2 3 4 5 6 7 and 8. Okay, so output shape can be understood from the here. So if you go to the documentation, you can see here for the same mode, I mean the max length should be max of m and n. Okay, so both have 8, so it will also give 8, and here you can output shape have max m. Okay, so max of m is 8. Okay, so it will give 8 length of array from convolution of this x, y, and y or mode CM. Okay, so you can see that it's like full mode. It has like taken care of your edges also, and this is like where the both array overlaps. So this way you can do the convolution of 1D data in Python. Okay, so here we have like 3 different modes: full mode, valid mode, and the same mode. So thank you.